In this question, we've got a European call and a European put option on the same stock. It tells us what the stock is trading at, the difference between the put option and the call option in terms of their prices, and the expiration date, as well as the strike price. That's the same as the exercise price. And we've got to calculate the annual effective risk-free interest rate. Okay, so whenever we've got questions with both calls and puts in them, the first thing that should kind of come to mind is put-call parity. So let's remember our formula for that. That means today we can purchase a call plus the present value of, let's say 1 plus I to the t, the present value of the exercise price that we would receive at time t, so at the end of the or at the maturity date. That's the same as if we bought a put option today plus the stock today, right? And you can again come up with scenarios for this. The price of the call plus the present value of actually earning the exercise price in the future is the same as purchasing a put today as well as the stock. And again, you can come up with scenarios there to see how each one will go up and down, but these will be equal. Otherwise, there's an arbitrage opportunity available. So let's look at what we've got. The key part in this question is when it says the put option sells for 15 cents less than the call option. Okay, so we don't know the price of the put or the call option, but we know the difference between the two. We know the call option is 15 cents more than the put. So why don't we get those two on the same side? Let's just rearrange this formula to C minus P equals S minus K over 1 plus I to the T. So that's just algebra moving things around. That way we know C minus P, we know that's 0.15. We know the stock today is trading at 65. And we know that the K value is our strike price. That's going to be 75 that we're going to earn at time t. And so in our formula, we discount that back at some annual effective rate of interest for 5 years is t. So now it's just simply solving for I. Let's see how that algebra works. 1.15 minus 65 equals negative 75 over 1 plus I to the 5. Now if we cross multiply, we're going to get 1 plus I to the 5 equals negative 75 divided by 0.15 minus 65. From there we just take the fifth root and then minus 1. So our final answer before we kick it in the calculator should be I equals the fifth root of negative 75 over 0.15 minus 65, all of that minus 1. So we get I equals 0.0295. which equals 2.95%. That is the annual effective rate of interest, so that put-call parity holds and there's no arbitrage. Again, these questions are pretty simple. It's usually just looking for one variable in this formula we have. The key is recognizing that there's both a put and a call in the question, so we have to use our put-call parity formula. You can always send us more questions like this, info@arnoldtutoring.com. Thanks.